So what kind of problem is this? Irregular, it's good to know. Total interior, yeah. Good. So I think you guys hit the two main highlights. Total irregular tells us, well, okay. First I would say interior, which I think you were just assuming, which is true. So it is interior, and then you have to pick, branch and pick, is it just total or is it each? And since it's irregular, like Bailey said, we can't, if this had all been, like all these numbers hadn't been here, we couldn't find the measure of each angle. So we'll use the total interior equation. And I should put INT at least here, so total interior equals 180 times n minus 2. What shape is that? In other words, what is n? Well, we should review the name too.
It's a hex.
Hex, so this is 720. Plug n, or plug 6 in for n, you'll get 720. Okay, and then the left side is another expression for the total, which just means add all this stuff up. Okay. Anyway, let's solve for x. It's mostly a calculator exercise at that point, right? Mm-hmm. And just to save a minute, what'd you guys get?
125.
125? Should I put degrees on there?
Yes.
Yeah, in this case we should, because why? Well, because x is a measure, it's a measure of an angle on its own. You guys go have lunch together and stuff?
We should. I should just start bringing lunch and just have all this maybe. This be an automatic Monday thing.
Yeah. Yeah.
Thanks.
It's because of you.
Me?
Yeah.
I'm not the one who doesn't get here on time.
No, it's just this class. It should just be.
So we need to keep reviewing these. We'll probably do another one tomorrow or maybe the next day, because this will make up a little part of your test on this unit. And if we do a quiz, also that. But otherwise, grab your notes. Let's review quickly what we wrote about kites from Friday. Oh, before we do, like as you're getting there, remember we defined a quadrilateral and a diagonal. Diagonal was lines connecting opposite vertices through the quadrilateral. And then we gave all these different properties of a kite. We had 5 of them. So quick reminder, you're going to have 2 pairs of adjacent congruent sides, meaning 2 pairs that are the same length that touch each other. So in this picture we had 2 short ones and 2 long ones. You're going to have exactly 1 diagonal that cuts the other one in half, and the short one is the one that gets cut in half. We have 1 pair of exactly 1 pair of opposite angles that are congruent. That's these 2. They are on the short diagonal. The diagonals are perpendicular. That's huge because that allows us to set up solving with the Pythagorean theorem. And then finally, the long diagonal bisects the angles. So only the long diagonal bisects the 2 angles. Okay? Just a quick reminder that, there it is. I said, hey, if you ever get stuck on properties, draw out a really extreme case, like really stretch it out, and then things start to become obvious. So it's obvious, hopefully it's obvious that this angle and this angle are not congruent. There's no way that they ever will be in this configuration because that's obtuse, that's acute. It also shows us that we have 2 long ones that should be the same and 2 short ones that should. Things like that. Okay? Oh, also, there's no way this long diagonal will be the one that's bisected. It's only the short one. Okay? So we ran through examples. Most of them were solving angles. So let me put this up here. Yeah, so like given this angle's 35, get these other 2. To do that, we had to know that that was 90. all four of them are, but that's the one we used to set up this kind of a situation where we're back using triangles again and knowing that there's 180 degrees in there. Okay, and just more, a lot of these were angle stuff like I said. We left off working an example from this slide, which was this one. And that was finally using properties of side lengths. So, I'm going to say this and then we'll continue that example. Looking at this list, we have 1, 2, 3 different side length properties. And sometimes students get them mixed up, okay? So I'm going to continue to tell you this all unit. This sheet will be full of like 20 different things by the end of it, maybe probably more, that you really can't just rely on having on your note card. You're going to need to know them here too. Did anybody read them over the weekend? Okay, so pick up with that this week, like spend a night or spend 5 or 10 minutes each night reading through them. Okay, to where it would be awesome for you if you could get to where you could just, I could hand you this chart and you could fill them out. Okay? Yeah. And I'm not going to make you memorize them in the sense that like you don't get a reference, but I promise if you don't know them pretty well, they're not going to help you that much. Okay? Or they can be not helpful. So, point of all that, 3 of these are side length things. Okay? 2 of them are angles. So let's go get back to that example. We'll pick up where we left off. This was in your boxes, so go find that. Let me remind you where we left off. So the problem was to find x, and we knew, just for a second, obviously you're not going to do this on yours, but we were given this kite and this statement. That's all we were given. So first thing we did was put what we knew on the picture, like label stuff. Then we started using properties to help copy it down. So look at the difference here. We know that that angle is 90. Why? Which property? Yeah. Good. Diagonals are perpendicular. Property 4. Okay? So the blue is the ones that we had to add based on properties. We knew that NM and LM are congruent. Why? Property 1. So saying that we have 2 pairs of adjacent congruent sides. So I just copied 37 over. And then we were told OM is 35. So that was an original. So steps so far. Label. Identify the properties needed. And use the properties to create a relationship, meaning like an equation that we can solve. So here's what we did. Property 1, 4 got us to that point. Now we have a right triangle. So I'm saying redraw and focus on just the right triangle. Okay? How are we going to solve this? So properties got us to here. Now we need to use properties to write an equation using that triangle. So what do we know about right triangle side lengths? These are not angles, so we don't have a 180. What's true about side lengths in a right triangle? Okay, we do need to be careful of the longest one. Well, this is Pythagorean theorem, right? So we have a squared plus b squared equals c squared. And so which one of those letters is the longest side? C. It has to be, right? Put a reminder if you don't remember. C is always the side opposite of 90, which makes it the longest side. Okay? Here's what we have now. 35 squared plus parentheses around the 2x minus 2 squared, and then that equals 37 squared. Any questions on that? How are we going to solve for x when it's trapped inside of parentheses, inside of a square? Gonna give it a shot? Well, we're gonna get a couple of big numbers, 35 squared and 37 squared. So let's go ahead and write those in there. So $12.25, $13.69. I'm gonna leave this right now. I'm gonna leave this square. How would you proceed from there? Sorry, I should have a plus right here. Plus. Working to get x by itself. What should we do next? Do you mind shutting that door? You could. You could do that. She said distribute. Don't write this, but this is how that would look. Squared means times itself, so if you distributed, you'd be doing that and multiplying it out. Okay? You can. That's going to make this harder. So I wouldn't recommend doing it that way. But it's not a wrong thing to do. Okay. What kind of equation is this? And your choices are, at this point, linear or quadratic. Huh? Is this last line of our work, this equation, I'm asking, is it linear or quadratic? How do we know it's quadratic? It's going to be an x squared, right? Okay. So, if you have them and you need them, pull out the notes from that. If not, what was the question that we always asked when we had a quadratic? Good. Is there a bx? Well, is there one? As it stands, is there a bx? No, there's not. Oh, I see what you're probably queuing on. It says 2x, right? But that's going to be squared. So right now there's not a bx. There's something being squared, but there's not a something x, right? That something x is trapped inside of the square. So what was our strategy when we had no bx term? Like our solving approach. Can you go put that in the box, please? Star was if there is a bx. What was the other one? So no bx quadratic, we're going to square root. Read me the steps if you don't remember them. First step is to do what?
Operate steps to get x squared or
We have the parentheses squared, right? We want to get that thing by itself. So how? What has to go? Not yet. We have to get it by itself first. So I'm saying, what do we have to get rid of over here for the squared thing to be by itself? Awesome. So subtract 1225. Before I do that, I just want to write here. No, so use square root. Anyway, so we're subtracting 1225, and then we get this 2x minus 2 squared. And let's go subtract that. And we get 144. Oh, how about that? It's a nice perfect square. Okay, what's the next step?
Square root results.
Yes, now we can square root, because now we can get rid of, since the squared thing is by itself, we'll be able to get rid of it. So square root, both sides. Okay, unfortunately we're kind of all over the place with this problem, but now we're going to get 2, can you guys see the yellow? That's probably, I'm going to change color, actually. So 2x minus 2 equals, what's the square root of 144? 12. Okay, and then look how nice and simple that solve is, right? What are we going to do next?
Add 2 to 12.
Yep, add 2 to the 12, and then divide, and we'll get 7. Okay. Do you remember when we square root, there's the negative version as well? So we did positive 144, or positive 12, excuse me. We also need to do negative 12. Okay, so maybe if you need that reminder, put the square root of 144 and then do our symbol. It's plus and minus, or positive and negative 12. Anyway, now when we add our 2, we get negative 10, and then x is negative 5. Does negative 5 work in the geometry? Algebraically, it works just fine, but in the geometry, it does not, because if I plug negative 5 right here, that's going to be negative 12. And I can't have OL be negative anything, right? So that solution is kicked out. It doesn't work. No, how should we say it without filling our whole box? Just say kick out. Okay, it doesn't work. So x is 7. Where did we leave off with the kite properties? Like, where did that part of our math stop? But where? I'm saying in this problem, where did that happen? It actually was clear back here. Right? Like, creating that triangle was a kite property. After that, this became Pythagorean theorem and algebra. And the kite property just helped us set that up. That's all. That's how most of these problems will go. You'll use a trapezoid property to set up something, or a parallelogram property, and then you'll solve with other tools. Just like we've seen all year, actually. Any questions on that one? These will not all be quadratic. So if that was an issue, that's, I mean, you need to know how to do it, but it's not going to be every problem. So any thoughts, questions? Okay, well, let me give you a chance to try a couple then. That was this one, so this one is done. We did this one on Friday. Not sure why the work isn't there. I wonder if I forgot to hit save. Okay, so let's have you try that one, and let's just see how long that one takes you first. All right, well, So, guys, big idea here, one of the big ideas is making sure everything gets labeled correctly before you even start. So, let me move this star out of the way. So, on here, we're told that OQ is 33. Let me put that on the side, so 33. RS is 65, and OR is 7X. So I hope that you're starting to get the feeling of how this unit will run, which is, hey, here's some figure with some lengths, solve. And I want you to start thinking ahead. If this is a test problem, you have to know it's a kite, you have to know the properties of a kite, and you have to know which properties to use. And that's a lot of filtering by the end of the unit, okay? So start building that, I guess, that skill of recognizing down to what you need right now. Start building that right now. Because as you look at that, like, if we had not just done an example on this, how would you relate those three side lengths? It looks kind of unrelated. It can. And probably 2 weeks from now, you'll look at it and be like, what did we do again? Right? Maybe not. Maybe it will build and get better, hopefully. Well, as soon as I know this is a kite, I'm looking at the property, seeing what I can apply. Okay? And here's what I mean. Like, I see kite, I've labeled, stop there, identify the properties needed. Okay? Don't worry about writing an equation just yet. There we go. So, could I use the fact that we have some congruent sides in this problem? Well, yeah. Like, I have a side length called 65. I should copy that over here. Maybe I don't need it. Maybe it won't help. But if it is helpful and I don't do it, that's a problem, right? I'm stuck. All right, next property. Exactly one diagonal is bisected. Is that helpful? Yeah, I mean, that means SQ is split in half. So that's also 33, right? Maybe I don't need that there, but maybe I do. So just, again, all we're doing is going through the property list. Do I know anything about any opposite angles? No? Like, I know they're congruent, but I wasn't told any angle measures, so I can't use property 3. Property 4, the diagonals are perpendicular. Yeah, you bet, I need that. That means this is a 90, and so is the other side. I only need to mark one of them. And finally, the long diagonal bisects the angles. So that doesn't matter in this one because this is a side length problem, not an angles problem. Okay, I want to demonstrate that over and over again. Find the kite properties, apply the ones you need. Now I'm looking at a right triangle. As soon as I see that 90 go in there, I'm at least going to be aware that I could use it. And it doesn't actually matter which side you use. But redraw. That's why we wrote it in our notes. Redraw the right triangle. And then, guys, this is kind of an issue that you need to address right now. If this is something that you're dealing with. I'm going to put it, actually I'll put it on that slide. These two are not the same thing. Why? What does the right one become once we square? What does the right one become? Up there at the blue. No, I'm saying once we do the squaring, what is it? What is this when we square? Yeah, the 7 is squared. In fact, let's even write that out. This is 7 squared x squared, which is 49x squared. Clearly not the same as 7x squared. Okay? You really do need to be careful with that. That's an order of operations thing. Okay, everybody clear? Any other version of that? Like if we did, I don't know, 7x squared. How about this one? Is this the same? If you wrote both of them as squared? That's the same. But that's a lot of extra potential for mistake there. Like you could maybe have to write it out. So, go plug these in. We get 7x squared plus 33 squared equals 65 squared. 49x squared plus, what is this one? What is 33 squared?
1,089.
And 65 squared?
2,225.
4,000, you said?
Yeah, 4,225.
Okay, subtract. All of this is fairly routine algebra. Now, I mean, from this point. What is that number? 3,000 something? Divide by 49. And we'll get x squared equals 64 and x equals 8. X also equals negative 8. Is that going to work? No, because that would make this side length negative 56, which isn't so good. Alright, good. How'd that go for you? I don't need to do that. Hopefully it's obvious that we are coming in and doing that. Yeah, Kyron?
You wrote 1,196 minutes of 36.
Oh, okay, thank you. So change the 9 to a 3?
Yes.
Good. Thank you. Alright, that's kites. Guys, that is not gonna, that's good examples of side length and angle solving. But it's not like every problem is gonna just be the same repetitive thing, okay? There will be differences in the problem somewhat. Any questions on it?